Hi guys, in today's video I would like to review my speech recognition AI that I've released almost 2 months ago. Let me tell you and explain what are the new features. The first thing is this training autosaving parameters, which automatically saves the training progress, starting the loss when it goes below 0.5, then under the 0.25, and then half of that and half of that. So it goes on and on. And now it automatically exits and saves the final weights when the average loss is reached or when it goes below the threshold. And I've also added advanced transfer learning, which means that you can also modify the topology a little bit, or you can add a new words to be recognized. So in that case, also the topology doesn't match perfectly, and it will still work because it creates new parameters with the random values around 0. And when it starts training, it will quickly correct those new neurons, and the rest of the neurons, if they will be really close to what's needed or what is represented by the training data, it will be mostly just a little bit changed or unchanged. And I've also renamed the terminology a little bit from error to loss, which is mostly used. Um, and also I've shortened the silence time when the recording automatically stops when the user stops talking. So that's new, and compared to previous version, there was only what I've called simple transfer learning, so the topology had to match perfectly, which means that you were able only to continue with the training, or you were able to replace a word with another word, or record new training samples, but the vocabulary to be learned has to be the same. So that was the difference. And when it comes to layout, it is mostly unchanged. Like it's the same when it comes to this training data layout or train AI, where you actually start the training. This speech recognition layout, when it converts actually speech to text. So this is the main part, it's the same. Also this settings part, where you have word routing feature, and also it's the same when it comes to advanced settings. But this is the new thing. You can see that what's related to this training autosaving. So it will show you like on what loss it actually saved the weights. So that's more or less the same, and you can still have this neural network visualization part, where you can see the time domain and frequency domain. And when it comes to this time domain, you can see the amplitude of the word, the outer shell of the spoken word. So we can see the intonation and the duration of it. And each word has different shape of in these last hidden layers. So that's quite interesting if you can compare them. So it's nice to see it, and even if you say the same word slightly differently, it will have slightly the same or almost the same shape in these last layers. And it will be, and if it will be a bit different, like if the word won't start to match, you will also see that the shape representing the typical word will start to lose its shape. So it's nice to see it visualized. And let me now explain you like what are my plans for the future. Over here you can also see my previous demo videos and reviews of my speech recognition AI. So let's start about my to-do list, what I want to do in the future. I want to introduce or implement what I've called weight ironing, which means that in these cases I do have recording that have various length, and the rest of the buffer in this time domain, let's say, is set to 0, and all the various words have various duration, and this phrase buffer has almost 3-second duration, so you can have a pretty much long recording, but each word or phrase can be only up to 3 seconds long. But if none of those words will have, let's say, will exceed 2-second duration, then the last second won't be even touched by training. So therefore, I've decided to check the maximum duration of the word or of all the words in the training database. And if none of them exceed, let's say, 2 seconds, then all the connection of the first hidden layer will be set to 0 of each neuron, because that way I will eliminate some false positive activations of those neurons because they haven't even been touched by the training itself. Because if none of these values were set different value from 0, they haven't been altered, or it's irrelevant what value those weights do have. And if I will introduce a new word or a random phrase that will exceed the training duration, the maximum duration of the training phrase, then it can activate random neurons based on the random parameters. But if I will set them to 0, if I will iron them, then those connections won't activate those neurons. So that's this feature I would like to introduce in my next release. Then I would like to also implement the full FFT. So as you can see, this is the frequency domain, which represents the frequencies present in each phrase. But currently I do have only the amplitudes displayed, which are technically real and imaginary values multiplied and square rooted. So I do have their amplitudes. But the thing is that that way I'm losing the phase shifts of those individual frequencies. So I do know what vowels and consonants were spoken, but I don't know in what order they have been spoken in those terms. So I'm losing some information about it. So I'm really interested, like if I will add new parts of the FFT, the real domain itself and the imaginary domain itself, I will have present more information there. But on the other hand, I will have several more connections from the input layer to first hidden layer. So my parameters in neural network will rapidly grow. So that's the other part of this added feature. So that's I will have to think about it. But I would like to also create a client application for the Android that will act as an IP microphone. So I will be able to talk to a phone and send a recording, and this way I will have a remote microphone. And when it comes to feed forwarding, so each layer can calculate its neuron individually, but I can make it more efficient by introducing and using parallel for each for calculating layer by layer, but all neurons in parallel. So it will boost its performance. So because currently I'm calculating them all one by one, like layer by layer, so it takes a while. And also I would like to increase the number of layers of the neural networks, so that will also make it more flexible. So that's all for today's video. I only wanted to review it, and if you want to see all my previous videos, these demo videos, you can check them on my GitHub, or I will put them down in the description. So that's all. Thank you for watching. Bye. See you next time.